Assalamualaikum and hello everyone. Today we will learn about new chapter 5, Hydrocarbons. In hydrocarbons, we have 5.1 alkanes and 5.2 alkenes. 5.1 alkanes. This is overview for 5.1. We have general formula, draw and name IUPAC nomenclature, physical properties, and the last one is the reaction. Learning outcome. At the end of this subtopic, we should be able to A. Define and classify hydrocarbons into first aliphatic and aromatic, second saturated and unsaturated. For B, we should know how to draw structure and name alkane compounds according to IUPAC rules. For straight chain and branch alkane, parent chain number of carbon equal or less than 10. Second, cyclic alkane number of carbon 3 till carbon 6. And the last one is alkyl group. Hydrocarbons. What is hydrocarbons? Hydrocarbons are compounds which contain only carbon and hydrogen atoms. Hydrocarbons are divided by two, aliphatic and aromatic. For aliphatic, we have saturated and unsaturated. Saturated hydrocarbons, compound with single bond, which is alkane. The example is ethane. For alkanes, it contains the maximum number of hydrogen atoms that the carbon compound can possess. For unsaturated hydrocarbon, compound with multiple bonds. Example, alkene and alkyne. For alkene, it has carbon-carbon double bond, and for alkynes, it contains carbon-carbon triple bond. This is example for alkene is ethane, while example for alkyne is ethane. For aromatic hydrocarbon, it must contain one or more benzene ring. The example is toluene. Now let's study how to draw and name IUPAC nomenclature of alkanes for straight and branch alkanes, cyclic alkanes, and the last one is alkyl groups. Alkanes are known as saturated hydrocarbon which contain only single covalent bond. IUPAC names have the N suffix. The general formula of alkane for straight chain is CnH2n plus 2, where N equal or more than 1, while general formula for cycloalkanes is CnH2n, where N equal or more than 3. Starting from C4H10 onwards, the alkanes show the phenomenon of chain isomerism. They can exist as linear or branch alkenes. Each carbon atoms in alkanes is sp3 hybridized, and the molecular geometry is tetrahedral with 4 sigma bond. This is example for linear alkane, which is pentane, and the branch alkanes 2-methylbutane and 2,2-dimethylpropane. Can you see differentiate between linear and branch alkanes? The table shows the first 10 unbranched alkanes. If the number of carbon 1, the name is methane, molecular formula is CH4, and the structural formula we can write as CH4. If number of carbon 2, the name is ethane, molecular formula C2H6, and the structural formula we can write as CH3CH3. If the number of carbon is 10, The IUPAC name is decane, molecular formula C10H22, and the structural formula we can write as CH3, CH2, 8, CH3. Now let's study about IUPAC nomenclature. What is IUPAC? IUPAC stands for International Union of Pure and Applied Chemistry. Naming branch alkane is slightly more complicated than naming the straight chain ones, so we need to follow a simple set of steps to arrive at a proper name. Step number 1. Choose the longest continuous chain of carbon atoms. This chain determines the parent's name for alkanes. Example 1. We have 6 number of carbon at the longest continuous chain, so the parent's name is hexane. Example number 2, we have 7 carbon at the longest continuous chain, so the parent's name is heptane. Step number 2, number the longest chain beginning with the end of the chain nearer the substituent. Example, so the substituent at carbon number 2. Example number 2. So we start from the bottom because it nearer the substituent. Step number 3. Use rule number 2 to locate the position of the substituent. The position and the name of substituent must be written in front of the parent's chain. Look at example. Substituent, which is a methyl, at carbon number 2, so that the name is (2-methyl-hexane). Example 2, the name is 3-methyl-heptane because methyl at carbon number 3. Numbers are separated from words by a hyphen or dash. This is some common substituents groups. Methane become methyl when it changes as a substituent. For propane, it can be propyl or isopropyl. Butane become butyl. Next, we have isobutyl, second butyl, third butyl, and neopentyl. This is example for cyclic and aromatic compound as a substituent. This is another common substituents groups. Step number 4. If the compound contains more than one identical substituents, use prefix as di, tri, and tetra. Di for 2 identical substituents, tri for 3, and tetra for 4 identical substituents. Look at example. Commas are used to separate numbers from each other. Example 2,3-dichlorobutane, 2,3,4-trimethyl-pentane. 2,3 we have commas, while 3-dichlorobutane. Step number 5. If two substituents are present on the same carbon atoms, use that number twice. Example, we have 2-methyl at carbon number 3, so the name is 3,3-dimethyl-hexane. Step number 6. If 2 or more substituents are present, give each substituent a number corresponding to its location on the longest chain. The substituent should be listed alphabetically. In alphabetizing, the prefix di, tri, tetra, third are ignored, except iso and neo. Example 1. The name is 5-ethyl 3,3-dimethyl-heptane. We should write ethyl first, followed by methyl because di is ignored. For example number 2, the name is 5-isopropyl 3,3-dimethyl-octane. Step number 7. If there are two chains of equal length as the parent chain, choose the chain with the greater number of substituents. Example, we have 1, 2, 3, 4, 5, 6, and 7 carbon as a parent. So the name is heptane, and we have 1, 2, 3, and 4 substituents. So the name is 2,3,5-trimethyl 4-propyl heptane, not 4-sub-butyl 2,3-dimethyl-heptane because it only has 3 substituents. Step number 8. If the branching occurs at an equal distance from either end of the longest chain, choose the name that gives the lower number at the first point of difference. If we count from the left, the substituent at the carbon number 2, 3, and 5, the name is 2,3,5-trimethylhexane. If we count from the right, the substituent at the carbon number 2, 4, 5, and the name will be 2, 4, 5-trimethylhexane. So, which one is correct? Yes, the above one, because the number is 2, 3, 5, not 2, 4, 5. Now, let's study rules in naming cyclic compounds. Cycloalkanes are alkanes which carbon atoms are joined in rings. It's also known as saturated hydrocarbon, and the general formula is CnH2n, where n equal to 3, 4, 5, and so on. Step number 1. Prefix cyclo is used to name cyclic compound with a single ring system. Example, C3H6 as a cyclopropane, C4H8 cyclobutane, cyclopentane for C5H10, and cyclohexane for C6H12. Step number 2. If only one substituent is present, it is not necessary to designate its position. Example, chlorocyclopropane, not 1-chlorocyclopropane. Methyl-cyclohexane. Step number 3. If two substituents are present, number carbon in the ring beginning with the substituent according to alphabetical order. Number in the direction that give the next substituent the lowest number possible. Example: 1, 2, 3, 4, 5, 6. So the name is 1-ethyl 2-methyl-cyclohexane, not 1-ethyl 6-methyl-cyclohexane. Example number 2. The name is 1,3-dichloropentane, not 1,4-dichlorocyclopentane. Step number 4. When 3 or more substituents are present, begin at the carbon with substituent that leads to the lowest set of locate. So we count start from 1, 2, 3, 4, 5 and 6. So the name is 1-chloro-3-ethyl 4-methyl-cyclohexane, not 4-chloro-2-ethyl 1-methyl-cyclohexane. Example number 2. The name is 1-ethyl 1,3-dimethyl-cyclopentane, not 3-ethyl 1,3-dimethyl-cyclopentane, because we choose the lowest set of locant. Step number 5. If a single ring system is attached to a single chain with a greater number of carbon atoms, or more than one ring system are attached to a single chain, then it is appropriate to name the compound as cycloalkyl alkene. Example: so the name is cyclopentylhexane. Cyclopentane become substituent. For this one, the name is 1,3-dicyclohexyl propane.